So a convex lens, for a convex lens, we had seen the image can be formed as real or virtual. So for different positions, we had seen the position of the object and position of image, position of object, and we had also seen the position of image and also its nature, position of image and nature. So when the object was at infinity, the image was formed at focus, image was formed at F, and the nature was real and inverted. You have real and inverted image formed at focus. This was for the convex lens. When the object was beyond 2F, you have the object beyond 2F. So the position of image, it was between F and 2F. Right? The position of image, it was between F and 2F. And the image was real and inverted. What was the size of the image? Yes, what was the size of image?
Diminished.
Diminished. The size of the image was diminished in both these cases. Then when the object was placed at 2F, the image was formed at 2F and it was again real and inverted and same size. This was also real and inverted but same size. Then when the object was placed between F and 2F, or you say F1 and 2F1, so image was formed beyond 2F2. It was again real and inverted but magnified. That is enlarged. Here image was enlarged. Real inverted and enlarged. Okay. Then we place the object at F. When the object is at F, the image was formed at infinity and it was highly enlarged. Real inverted and highly enlarged. Finally, we kept the object between focus and finally we kept the object between optic center and focus. So we obtained here the image is formed before the lens. The image was formed before lens and it was a virtual image. So this was the only case when a convex lens forms a virtual and enlarged image. Got it? So it was only this case where we observe a convex lens forming a virtual and enlarged image. Okay. Then we had seen the image formation by concave lenses. For the concave lens, there were just two cases which we studied. So for the concave lens, we had seen when the object was at infinity, object, you have image, and for image we can write its position and size.
Sir,
Position,
could you show the previous page? I'm still writing.
okay. So yeah.
Thank you, sir.
Sir, wait a minute.
So all these you will be able to remember once you remember the ray diagrams for the different cases. Got it?
Yes.
Okay, so shall we move next? Yeah. So for the concave lens, when the object was placed at infinity, the image was formed at F1. Nature of the image was virtual and size was diminished. or small. Then when the object was placed at finite distance, at any of the finite distance, when the object is placed at a finite distance from the lens, so you observe the image to be formed before the lens, anywhere it before the lens between optic center and F. So here we had seen the image to be present between optic center and F, O and F. The image was virtual and diminished. So here also image was virtual and diminished. So these were the various cases of the image formation by the concave and convex lenses. So we had seen that it is only the convex lens which can form the real images. Only the convex lens can form real image. Otherwise, concave lens can form only the virtual images. It cannot form any real images. Got it?
Yes.
Yes. A virtual and enlarged image is formed by a convex lens, which makes it suitable to be used as a magnifying glass. So a convex lens can be used as a magnifying glass if the object lies between the optic center and the focus. Now we will be doing the lens formula and Cartesian sign conventions. So here the lens formula states that 1 by f is equal to 1 by v minus 1 by u, where the symbols have their usual meanings. That is, the u is your object distance, v is image distance, and f is the focal length. Now, in this lens formula, we obtain the formula of magnification also. Magnification m is given by height of image hi by ho, which is equal to v by. See, in the case of lens, in the case of mirror, the magnification was given by the formula minus v by u, and here the magnification is given by the formula v by. In the mirror formula, the mirror formula was 1 by f equals 1 by v plus 1 by u. Here the lens formula is 1 by f equals 1 by v minus 1 by u. So this is the difference of the sign that occurs between the lens and the mirror. Okay. And this difference is because in the case of mirror, there is reflection, whereas in the case of lenses, it is refraction. The light ray passes through the lenses. Now for both of them, let us see some of the questions where we can use these lens formula and try to find out the characteristics of the image.
Sir, can you show the previous page once?
Yeah.
So magnification was minus V by U, right?
No, V by U.
Sir, done, sir.
For mirror, the magnification was minus V by U, but for lens, the magnification is just V by U.
Okay, sir.
Okay. Now, can we start with the question?
Yes.
Okay. Okay, so I'm sending the question through your group, and I'll share here also. Okay, see, you can check. You have the question in the group. I'm sharing the question here also. The question says, an object of height 2 centimeter is placed at a distance of 8 centimeter from a convex lens. So let's see here. Just 1 minute. Let me check. Okay, I think I need to write down it. It's currently not opening here. Okay. All of you have got it through the group. Just check it that you have got through the group. Okay. So I have the question. Let me present the screen again. Everyone share your screen. Sorry, turn on your camera. Okay, so are you able to see the screen? Can you see the question here?
Yes.
Okay.
Yes,
So
sir.
an object of height 2 centimeter is placed at a distance of 8 centimeter from a convex lens of focal length 10 centimeter. Calculate the position of image, the size of the image, and state the characteristics of the image. So first of all, tell me what all information we get. Which can we guess that which type of diagram is it talking of? Can you guess which diagram is it talking of?
Like
Okay, where is the object placed?
8 centimeters from the lens.
8 centimeter from
The lens.
okay, 8 centimeter from the lens. And where what is the focus? Focal length
10 centimeters.
10 centimeter. If the focal length is 10 centimeter and the object distance is 8 centimeter, so which of the diagram are we talking of?
Object between pole and pole,
Object between
pole and
no, there is no pole. It's the object between focus and optic center. Okay, it is the object between focus and optic center. Got it? So, which type of image should be formed here? Should it be real image or virtual image?
Virtual? Virtual.
Yeah, it should be a virtual image. So, what should be the value of, should the value of V be positive or negative? What can we say about the value of V? Should it be positive or negative?
Negative. Negative.
See, it's a lens. And in the case of lens, we had seen that when a real image is formed, the real image was formed on the other side. Here was the image formed and here was the object. So the object distance was taken as negative. So image distance will be positive, right? But for this case, we observe that it is a virtual image. So image will be formed on the same side and hence the image distance will be negative. So all of you are correct. Now calculate this using your lens formula. Calculate this.
Sir,
Use the lens
image distance is coming minus 40 centimeter.
minus 40. Okay. So you have got the position of image. What is the size of image then?
10,
Obtain size and the
10,
characteristics.
10 centimeter.
10 centimeter.
Yes, sir.
Okay. So you will use the formula 1 by F is equal to 1 by V minus 1 by U. Carefully putting the values, we obtain F to be plus 10 centimeter. We use U as minus 8 centimeter. So the formula would be 1 by 10 equals 1 by V minus of 1 by minus 8. So you get 1 by 10 equals 1 by V plus 1 by 8. Transpose the term, transpose this 1 by 8 to the other side. You get 1 by 10 minus 1 by 8 equals 1 by V. Taking the LCM, you get the LCM as 40. So you get 4 minus 5 equals 1 by V. And hence we get V as minus 40. So you get minus 40 centimeter as V. You can solve it out and obtain the value of V to be minus 40 centimeter. So everyone has obtained the value of V.
Yes, sir.
Now let's say find the value of magnification. So magnification will be equal to V by U. V we obtained here minus 40 divided by U, which is minus 8. So magnification would be 5. Right? Another thing is given, height of object is given. So can we find the height of image? See, height of image by height of object. This is equal to magnification, which we obtained 5. So height of image will be 5 multiply the height of object. So height of object here is 2 centimeter and hence height of image will be 10 centimeter. Anyone having any doubt?
Sir, 1 minute.
No,
Sir.
sir.
Okay, so everyone got this and we can state the characteristics. So what would be the characteristics of the image?
It is virtual and erect.
The image is virtual and erect. It is enlarged and it is formed before the lens. Got it? Okay, let's try to do another question. So I'm sending you another question. We'll do one more, one or more questions just now. Wait for 1 minute. I'm sending it in the group and then you'll get here also. So please check. I have shared it. Have you got the access to this? See. We have the question here. An object 4 centimeter high is placed at a distance of 40 centimeter from the optical center of a concave lens of focal length 20 centimeter. Calculate the position of the image, size of the image. Also state the characteristics of the image. So now you are using a concave lens. So what should we write the value of focal length as? Yes, what we will write the value of focal length?
20 centimeter.
Plus 20 or minus 20?
Plus.
It is a concave lens, so focal length has to be minus 20 centimeter. The object distance has to be minus 40 centimeter. And now you have to find out image distance. For the concave, whether it's a lens or mirror, if it's concave, so its focal length is negative. And if it is convex, so the focal length is positive. Okay. So anyone got the value of V? Yes, who got the value of V? We have 1 by F equals 1 by V minus 1 by U. Anyone who got the value? So you have minus 1 by 20 minus 1 by 40 equals 1 by V. So now you can solve it taking 40 as the LCM. And you have here minus 2 minus 1. 1 by V. So it is minus 3 by 40 equals to 1 by V. And hence V is equal to minus 40 by 3. Okay. So what type of image is formed? Real or virtual? Yes. What type of image is formed? Is it real or virtual?
Virtual.
Virtual. The image distance is negative, so the image is formed before the lens, and hence it is a virtual image. Okay. Now we can find the magnification. The same thing, the same steps we have to repeat as the previous one. Find the magnification and find the height of image. So your magnification V by U, which is minus 40 by 3 divided by 3. So divided by 40 minus 40 minus 40. Yeah. So you get here magnification as 1 by 3. Now you can find the height of image. You can use HI by HO equals 1 by 3. So height of image will be equal to 1/3 of the height of object. So height of object here is 4 centimeter. So it will be 4 by 3 centimeter. Okay. So height of image is 4 by 3 centimeter. Now I think everyone can solve the questions regarding this. Yes? Can you people solve the
Yes, sir.
questions regarding this?
One more example.
One more example. Okay. So see, instead
Sir,
of
1
doing the
minute, sir.
example, yeah, just do this question, and I'm sending you some of the assignment right now in your group. You can practice those, and if any question from that you are not getting, so do ask that. So see, I have sent it through the group. You can practice all the questions from refraction. These are the questions from refraction. So you can practice those questions. And right now we can move forward. Here are the questions of length. They are there. Right now we move forward to the power of length. So let's see what is the power of length. What do we mean by power of a length?
Sir, could you show the previous page, sir, once?
Yeah,
Last part
just
only
one,
left.
just 1 minute.
Okay, sir. Thank you, sir.
Okay. Now see, as we have seen, what is power of the lens? Power of lens, it is defined as the converging or diverging capacity of a lens. So power of lens, it is defined as, say, it is the converging or diverging capacity of lens. Converging or diverging capacity of a lens. So how much it is able to convert or how much it is able to diverge. For example, we know that the convex lens is a converging lens. So how much it can, how powerfully can it convert the light rays? So what do you think? A lens having a larger focal length. See, compare these two lenses. I'm producing here two lenses. These are the two lenses. So one of the lens, I'll show you the light rays passing through both of them. So through this lens, you have the ray of light which are passing, and the parallel rays of light, they are converged at this point. For the second lens, also here you have some light rays passing, and these light rays, they are converging here. So which one of them do you think is more powerful in converging the light rays?
The first one.
Yeah, the first one. So here, this one is more powerful. I can say the power of this lens is higher. So this lens has a high power. Why high power? Because as it has the higher capacity to converge. Whereas this lens will have a low power as it has a low capacity to converge. If we observe the focal length, so it has a small focal length and it has a large focal length. So can I say that power will be inversely proportional to focal length? Yes or no?
Yes,
Can I
sir.
say? Yes, the power is inversely proportional to the focal length. So I can write also power is equal to 1 by f. This is the formula for power. Power is measured as 1 by f, where focal length has to be given in meter. So either you take the focal length in meter or you use the formula P equals to 100 by f. If you are taking f in centimeter, so you use the formula 100 by f. Or if you are taking your f in meters, so you will be using this formula. Power will be equal to 1 by f taken in meter. Got it?
Yes,
Any
sir.
doubts? The power of a lens is measured in diopters. The unit of power is measured in diopter or D. Diopter denoted by D. Now let's start with some questions here? Okay, so let's start with the questions.
Sir, could you show the previous, sir? I have to stall it.
Yeah. Okay, so can we move ahead to questions?
Sir, last thing, sir, 1 minute. Yes, sir. Thank you, sir. Completed.
So see here, you have to find the focal length of a lens. A lens has power of minus 2D. Which type of lens is this? So which type of lens is this? Okay, so can you answer these questions? A lens has focal length of, a lens has a power of minus 2D. Which type of lens is this? So what is the type of lens?
Concave.
Concave. Okay, since we observe here the power is negative, so negative power means the focal length is negative. So it is a concave lens. And what is its focal length?
Minus 1 by
Minus.
half. Minus half.
Okay, let's try to do this. You have been given power as minus 2D. Use the formula power equals to 1 by F. So this is minus 2D equals to 1 by F. So remove this D. We don't need to write this D here. We have F equals to 1 over minus 2. This is F is minus 0.5 meter. Now you convert this into centimeter, you get 50 centimeter. So the focal length of the lens is minus 50 centimeter. Got it?
Yes, sir.
Yes? Any doubt?
No, sir.
So let's do another question. A lens has focal length of 15 centimeter, not say 20 centimeter. What is its power? Find its power. What is the power of the lens? So what will be the power of lens? A converging lens has focal length of 20 centimeter. Find its power. What will be the power of lens?
1 by 20 centimeter.
1 by 20 centimeter. Remember, you have to change it into, you have to change centimeter to meter, or you have to use the formula 100 by F. So, what is the answer?
5.
5.
5.
Yes. Also, we have to take focal length positive. So, power has to be 100 by F, F taken in centimeter. So, you will be getting here 100 by 20, which is 5D. So 5 diopters plus 5D is the power of the lens. Got it? So all of you do the questions which have been sent in the group. Okay. Okay, bye all of you. See you again in next class.
Sir, bye, sir.
Thank you, sir. Bye, sir.